Today, 40% of Africans live in cities. By 2030, this number is expected to increase to 50% and 70% by 2050. This growth is met with rapid urbanization and increased demand for basic services such as energy and water that are essential for cities to operate. Today, it's estimated that 75% of Africa's energy demand comes from cities, and 40% of this comes from buildings. It is also estimated that 75% of the buildings that will stand in Africa in 2050 have not yet been built. Therefore, we need to fundamentally change the way we design our buildings to minimize consumption of our limited resources, such as energy and water. Here are some important sustainable design strategies to consider when designing and constructing buildings. Do some site analysis. Gather context-specific information such as climatic data and other attributes of the site, such as the terrain, and design in response to them rather than against them. Building less is always better. Retrofit old buildings and give preference to readapting overgrown and brownfield sites over underdeveloped greenfields. This reduces demand on building materials and saves costs. The less the building footprint, the better. New buildings should not exceed 60% of the plot. Design buildings with the longer sides facing north or south. This minimizes exposure to direct solar radiation and heat gain from the sun, and saves energy that would otherwise be used to cool the building. Design buildings to be narrow in plan because they are easy to light and ventilate naturally, especially for hot and humid climates. For hot and arid climates, compact forms with internal courtyards are recommended to retail cold air in the building and minimize heat gain. Services such as toilets, staircases, lifts, and lobbies should be located on the east and west-facing facades to act as buffer zones and prevent heat gain. The size of openings matters. The ratio of the size of the windows to the walls should not exceed 30%. This prevents unnecessary heat gain in buildings that will require energy to cool down. Maximize use of natural light. This reduces energy costs and overall well-being of building occupants. This can be done by use of clerestory windows and light shelves. Consider sun shading strategies such as deep roof overhangs, balconies, horizontal and vertical shading elements, screens, or green walls. These help to minimize direct solar penetration in buildings, improve indoor comfort, and save energy costs in the long run. Design for natural ventilation. Design for both cross and vertical ventilation by considering narrow buildings and providing roof vents, thermal chimneys, or clerestory windows. Give preference to building materials that do not transmit unnecessary heat into the building. Also, always give preference to locally available building materials, and recycled materials are also recommended. Light-colored finishes are recommended on external faces to reflect excess solar radiation and on internal faces to increase internal reflection of natural light. Also consider green walls and vertical gardens that can help maintain cool microclimates. Incorporate renewable energy such as solar panels, solar hot water heaters, wind energy, biogas, and other renewable energy systems into the building design. These reduce our carbon footprint and reduce costs in the long run. Incorporate rainwater harvesting systems to reduce dependence on the national grid. Also, specify water-efficient appliances and water-saving fixtures to minimize consumption of potable water. Stormwater drainage is also important. Design paved areas to enable stormwater infiltration. This reduces runoff, flooding, and replenishes natural systems. In absence of municipal sewage system, design for on-site waste treatment. This can be used to produce biogas that can provide extra energy for cooking and lighting. Provide on-site waste sorting facilities to ease waste collection and promote recycling. Limit paved areas around buildings and design for soft landscaping to reduce heat island effects. Landscapes with native plants are recommended because they require minimum irrigation. Specify energy-saving appliances and mechanical equipment. Make use of energy-saving bulbs, light level sensors, motion sensors, and energy demand management. Also, encourage behavioral change to reduce unnecessary energy consumption.